Hi, I would like to briefly demonstrate how to calibrate Mini VNA Tiny. This is the Mini VNA Tiny. Now, we will need to connect the Mini VNA with a laptop or PC by using USB cable. Once you have connected successfully, look for the folder of VNA. Double-click to open the driver. Go to the tab of Analyzer and click Setup. Make sure that the available driver stated Mini VNA Tiny, and for this computer the available port is COM14. In order to ensure that the device is functioning properly, we will need to test the performance. Click Test. Then the status will say that the driver and port are working properly. Click Update. Once we have connected the device successfully, go to the tab of Calibration and click Create. Now you can see that there is Open, Short and Load. Firstly, remove the rig cap from DUT connector. This is the DUT, stands for Device Under Test. Once you have removed the cap, we can connect it with the open circuit kit. This is the open circuit. Connect it to the DUT connector. Make sure that it's connected tightly, and now we can click this button to read Open. This graph shows that the open calibration is completed. Now we can remove the open circuit and replace it with short circuit kit. This is the short circuit kit. Connect it to the DUT port. Once it's connected tightly, click this to read short. After a few seconds, the calibration of short circuit is completed. Now we can replace it with 50 ohm match load. Remove the short circuit from DUT port and replace it with 50 ohm match load. Then click Read Load. The one-port calibration is now completed. Click Save. For this part, click Save as well. And for this file, I'll click Overwrite. Then click this green button to update. After the calibration process, we can now start our measurement. This green button indicates the magnitude of reflection coefficient in dB, whereas this blue button indicates the phase of reflection coefficient in degree. We can now start our measurement by clicking the single scan button. The green line represents the magnitude of reflection coefficient, whereas the blue line represents the phase of 50 ohm match load. Here are the values in dB, and here are the values in degrees. In order to enable continuous scan measurement, take Add Free Run. As you can see, this is the speed of data extraction. We can adjust this to speed up, whereas this is the average of data extraction. We can also adjust this to improve the accuracy of measurement. Thank you for your attention.
Hi, today I would like to briefly demonstrate how to connect water pump with match load waveguide adapters. First, we will need a water tank, water pump. The water level should at least cover the water pump. We will also need pipe and 2 waveguide adapters. Now we will need to use the pipe. As you can see, there is a pipe adapter at the end of the pipe. We will now connect it to the output terminal of the water pump. The pipe is divided into 2 branches. The first branch will be used for the first waveguide adapter, whereas the second branch will be used for the second adapter. Firstly, we will need to remove the screws. Then, put the screw through the water pipe. Next, attach the pipe to the connector. If possible, screw it gently to ensure that it's connected tightly. Then, we'll repeat the steps for the neighbor pipe. And attach it to the next connector. After that, we will put the end of the pipe through the cover. And place it into the water tank. As you can see, we have completed the repeated steps for the second adapter. This is the complete setup. Now, we will connect the socket to the power supply. Once it's connected, we can switch on. Now the system is operating and the water will be pumped into the match-load waveguide adapter and circulate back into tank. The water is a medium to absorb microwave energy and also act as a cooler. Before we begin the material heating process, we will need to conduct waveguide cavity coupling matching procedure to optimize the absorption of microwave power for the material. At the same time, it can also reduce the reflected wave phenomenon. The system consists of match load, applicator, sample holder made by quartz glass. In this case, the water is used as a sample for heating. We will also need 3-screw tuner, waveguide coil adapter, and calibrated vector network analyzer VNA. Now we have combined all the components using screws. First, we will need to remove the cover of applicator by removing the screws. Then we will need to lift up the cover. Here, this is the waveguide cavity. Now we will need to put the sample into the cavity. Now the cover is closed. We will need to put the screws back into its place. Now the VNA is calibrated. We have demonstrated the steps of calibration previously. Once the calibration process is completed, we can remove the 50 ohm match load from DOT port. And connect it to the waveguide coaxial adapter. First, click Add Free Run, and then we will need to change the speed to ×4, which is maximum. Then, we will need to disable the phase measurement and change it into none, so that we can only refer to return loss. After that, we will need to put a marker line here. In order to do that, we will need to edit the setting. Click at this icon and tick Add Marker as Vertical Line. Then we click Save. Now we will need to adjust the marker line at approximately 2.45 GHz. This is due to the signal generator will only generate frequencies around 2.45 GHz. Now we will need to adjust the 3-screw tuner in order to shift the minimum peak of reflection coefficient to 2.45 GHz. This will also ensure that the reflected wave is at the minimum level. In addition, the cavity coupling matching will also be achieved. In order to shift the minimum peak, we will adjust the first screw. Then, in order to minor adjust the achievement, we will turn the third screw. Last but not least, we can use the second screw to further improve the achievement. From the graph, you can see that the minimum reflection is achieved at 2.45 GHz after the tuning process. Once the cavity coupling matching calibration is completed, we will remove the waveguide coaxial adapter and VNA. Then we will connect the generator, and this port will act as an isolator to prevent the reflected wave back to the signal generator. Now we will switch on the generator. As you can see, this is the microwave generator station. This button is to control the DC power supply to a magnetron, and the LCD screen will show you the reading. In fact, the microwave output power is controlled by the DC power supply. You may refer to this graph, in which the x-axis represents the DC power supply, whereas the y-axis will represent the microwave output power, which will be released from the waveguide. Now, we can monitor the temperature of the sample by using this thermometer. Firstly, switch on the thermometer and the light. Next, immerse the thermocouple into the sample. As you can see, the temperature is increasing slowly.